So 7a and d is what I just asked you to do. So let's go to 7a, find the constant term. So again, we need a general term. So 6 choose k. Let's do the first term to the power of 6 minus k, and the second term to the power of k. So looking just at the powers of x in this case, from this bracket we would have x squared to the 6 minus k, so that's the same as 12 minus 2k, and this one would be x to that minus k because x is at the bottom there. So if we want a constant term, we want x to the 0. So let's have a look. That would be 12 minus 3k's would equal 0 if I just equate the indices. So 3k would equal 12, so clearly k equals 4. Now if k equals 4, if we put that back in here, k equals 4, we've got 6 choose 4. We can actually keep the x in there and just check that it works. So we've got the x squared on the top to the power of 6 minus 4, which is 2. So x squared squared, so x to the 4. Now on the bottom you've got 2 squared, so that's just a 4. Okay, next one, 3 to the power of 4, 3 3s and 9 9s are 81, and on the bottom x to the power of 4. So yes, it does give you a constant term, and that constant term is, what is 6 choose 4? That is 15, so we've got 15 times 81, and we're dividing by 4. So we get 1215 on 4. 1215 on 4, or you can write a decimal, but that's what we get for that. So let's have a look at our D, I think I said. So here's D. General term would be 12 choose k. Again, x to the power of, let's do 12 minus k. And the second term, let's do k. So it doesn't matter which way we do that, but whatever you choose. So again, this is x to the power of 12 minus k. This one gives us x to the power of negative k because x is on the bottom, and we want the constant term, which is the term without the x. So we want x to be to the power of 0. So we equate indices. So here we've got 12 minus 2k equals 0. So 12 is 2k, so k must be 6. So if I put 6 back in here, I've got 12 choose 6. 12 choose 6, which is 924. We can check by putting it in here. So 12 minus 6 is 6, and you can see that x to the power of 6 on the bottom is the other one. So I've also got minus 4 to the power of 6 there. So minus to the power of 6 is still going to be positive. So it's positive there, and it's 4, whatever 4 to the power of 6 is. So if I times by 4 to the power of 6, what do I get? I get another large number. That could well be wrong because my calculator skills are not great, but check for me.